At this precise moment, on a planet far, far away, an alien sunrise ushers in a new day. But will alien eyes gaze upon it?
For me, the most exciting question in the universe is whether or not there are inhabited planets other than the Earth.
What are the chances that out there in the Milky Way, there is other complex, advanced life like our own?
Today, our telescopes are combing the skies, discovering bizarre worlds, even in places they shouldn't be.
We didn't even know that that kind of planet existed. So it completely shocked our theories of planets and how they form.
Will we ever find a world that resembles our home?
Earth-like planets that orbit their stars at the same distance we orbit the sun are very difficult to detect.
Looking for life is not easy, and we're gonna get constant setbacks.
Are we finally on the verge of answering the ultimate question? Are we alone?
I think we'll actually find the answer while I'm still alive. At least I hope so.
The search is on. Alien worlds, right now. The Milky Way, our galaxy. As many as 400 billion stars. Spread across 100,000 light years. Among these stars, the Sun, with 8 planets orbiting around it, including our home.
Humans have been looking up at the stars for millennia. I think we're just so curious about it, yet we don't really know what's out there.
Not only what, but who?
We've gotten to the point in astrophysics where I think the big question on everyone's mind really is, are we alone?
Is all life like us? And will we recognize it when we see it?
Today, we stand on the brink of answering these questions.
What is different today is that we have a chance to actually address some of these issues quantitatively, scientifically, not just sheer speculation and philosophically.
If and when we do find life, it's gonna completely change the way we view ourselves, our planet, our universe.
Over the last 50 years, humanity's robotic space probes have found their way to every planet in our solar system. And even some of their moons. But so far, no convincing evidence of life has been discovered. As far as we know, Earth remains one of a kind. The only world where chemistry gave rise to biology. But even as the exploration of the solar system continues, another quest has begun to discover other planets out there orbiting distant stars. Exoplanets.
It's really only in the last few decades that we've had the ability to search for exoplanets.
And from the start, scientists dream of finding one that might host life like our own.
It's completely reasonable to expect that alien life will be quite different from the life we find on Earth. But Earth is the only place in the galaxy that we know for sure hosts life, so we start there, looking for an Earth twin. And then the question becomes, how common are Earths across the galaxy?
Over the last 3 decades, scientists have deployed some of the most powerful telescopes on Earth and used a clever technique to detect the presence of planets that are too dim to see next to the bright stars they orbit.
Many teams started to look for planets using the same technique. This is the Doppler technique, or the wobble technique.
The way the wobble method works is that you can imagine that you've got 2 dance partners, okay? One is the star, and one is the planet. But you don't see the planet because it doesn't put out much light. And so if we look very carefully at the star, we can see that the star appears to be moving away from us and towards us, back and forth over time. And we can deduce just from a basic understanding of gravity that there must be something else there, and even measure its mass.
But what astronomers discover is something completely unexpected.
The first ever exoplanet that was discovered around a sun-like star was 51 Pegasi b in 1995.
"51 Pegasi b is a gas giant, around half the mass of Jupiter, but so close to its star that part of its atmosphere may have been ripped away.
These planets are baked by their star's radiation. The temperatures are in the thousands.
Many astronomers didn't believe it because the planet was in the wrong place. It was enormous, it was massive, and yet it was parked right next to its star.
And a planet has no business being there. There's not enough material around a forming star to make a planet that close to the star.
Its skies whipped into titanic winds, and a hot interior pelted by raindrops of molten iron.
The discovery of 51 Peg meant that we had to tear up the rulebook.
We were hoping to discover a planet, something like what we see in the solar system, but instead found a planet that had absolutely no analog in the solar system, and no one could have predicted that such planets were even possible.
And other discoveries were stranger still. Planets blasted by fierce radiation. Their surfaces battered and stripped by the high-energy strobing light of their star. Rocky worlds, large enough to hold onto some atmosphere, but so cold that the entire surface has frozen over. And great puffy planets with an average density like styrofoam. And with diamond-crushing pressures at their centers. These discoveries electrified the world's astronomers. At long last, confirmation that there are other solar systems out there, inhospitable though they might be.
These worlds are truly amazing places, and we've learned so much about the physics and the chemistry of a world like this. But they are not places to look for life.
Because these are worlds too bizarre, too large, and often too close to their stars for living things to survive.
Like any major scientific revolution, looking for life is going to be filled with setbacks and many false positives, but we have to keep on.
It's a lot easier to find something that's big and far away rather than something that's small and far away. So the fact that we've found more large planets is not an indication of what's actually out there. It's just a matter of what's easier to find.
Finding planets like Earth would take an extraordinary mission.
We really needed a space mission dedicated to finding Earth-sized planets in our galaxy, and ideally enough of them to give us real insights.
The solution? A telescope, almost 20 years in the making.
I was working for NASA Ames. I realized that if we were going to find Earth-sized planets, we had to build a photometer that was good enough to see these small Earth-sized planets and find out about them. Some 17 years after I started, NASA headquarters said, yes, we will build that mission.
I was very privileged to be at the Kepler launch, and we were all incredibly nervous a few days before because the previous mission that had launched on the same rocket had failed. Their satellite went down in Antarctica, and we were like, uh-oh, no. So we were very nervous.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Turning your engine, changing pressures are building. Outlet solid motors are built to containment pressure. And we have separation.
It was a spectacular night launch. Kepler was launched without a single flaw.
NASA's Kepler Space Telescope takes the search above Earth's atmosphere into space. Kepler travels 94 million miles away. Until it arrives on a stable orbit around the Sun, where it looks out with a fixed and clear gaze to a single patch of sky in the constellations of Cygnus, Lyra, and Draco.
What was special finally was the lid opens up and we see the nighttime sky. What we see is the sky is covered with stars. Every detector is working.
Exposing 42 incredibly sensitive light sensors to the light of 150,000 stars. Kepler begins its search for Earth-like worlds.
The problem with finding exoplanets is they just don't shine at all, and they're around really bright stars. That makes them virtually impossible to image. So, astronomers came up with a different method, and that's called the transit method. Kepler uses the transit method for discovering planets around other stars. And it's really simple. A star is bright. And if a planet is orbiting it, if the planet passes in front of the face of the star, the planet blocks some of that light and the star temporarily appears dimmer. So if we were to bring that down to Earth, imagine this lighthouse is your star. It's your source of light. If a moth flies in front of that light, even though to your naked eye the light looks the same, it actually has become a little bit dimmer because the light has been blocked by the moth. That's the transit method.
At the time, the largest camera ever launched into space, Kepler is able to look for smaller, more Earth-like worlds. Those too small to be easily found using terrestrial telescopes. Soon, it starts to spot planets.
The amount of dimming and the time between each dimming event gave us clues to a planet's size and its distance from its star.
And with every world it finds, astronomers hold their breath, hoping for a rocky planet that might in some way remind them of Earth. Worlds like Kepler 36b. Orbiting a star similar to our own. At first glance, a planet that resembles ours.
So when we started finding these rocky planets like Kepler 36b that were getting closer to Earth mass, it was just the greatest feeling.
Weighing in at around 4 times the mass of our own planet, Reed found one of the first rocky worlds that could have an atmosphere, a so-called super-Earth.
What's so cool about Kepler is that it tells us so much more than just the planets exist. We get their sizes, we get their orbital characteristics, we can get their masses, and so what we're learning is not just that the planets are there, but what these planets are like.
But the more closely we examine Kepler 36b, the clearer it becomes that this is not a world like our own.
Finding exoplanets in the Kepler data, you really have to do some detective work. You're trying to find a signal that's less than 1% of all the other things that are going on in that data.
The light from the star dims every 14 days, the length of a year for the orbiting planet. This rocky world orbits incredibly close, and it has company. A gigantic, gassy companion planet.
The discovery of the Kepler 36 system is really interesting because the first planet found was Kepler 36c. That's a gas giant planet.
The two planets have unusually close orbits, creating bizarre conditions on the surface of Kepler 36b.
Kepler 36b, in many ways, is Earth-like, but it also is very un-Earth-like in pretty profound ways that mean it's unlikely to have life on its surface.
Thanks to its close-by star, the planet's rotation becomes tidally locked. One face rests permanently under its star's bright glare. Punishing heat likely turns the ground molten. creating rivers of lava that crisscross the surface. On top of that, every 97 days, the immense gravitational pull from the gas giant may trigger intense volcanism on the smaller planet. Each time it passes between the giant and the star. Throwing lava high in violent eruptions. But Kepler-36b is a planet of molten rock, fire, and ice. Because its far side permanently faces away from the star, creating a frigid hemisphere shrouded in eternal darkness, where magma freezes into a strange, desolate landscape.
The Kepler-36 system is a perfect example of how exoplanets are completely different to what we know in the solar system.
Kepler-36b is just one of the first among hundreds of super-Earth-sized planets that the Kepler telescope discovers. The more scientists look, the more they find.
At the time that the Kepler mission launched, the team was hoping they might find a few exciting planets, and they were very prepared to analyze those data. Within the first few months, we realized that we did not have enough people to handle the deluge of planets.
The mission shows beyond doubt that our galaxy is home to a multitude of diverse alien worlds.
Kepler was a game changer for exoplanets. It was a game changer for us here on Earth, understanding that there are planets in their thousands, in their millions, in their billions in our galaxy alone.
We suddenly had this new problem. We had gone from just having a handful of planets to hundreds of planets to look through. So we needed to tighten the net, focusing on planets that didn't just resemble Earth's size, but its habitability.
Now that they have discovered that planets are plentiful, astronomers must narrow their search to home in on hard-to-find planets. Rocky worlds that hold the one precious ingredient that makes Earth a living world. Everything we know about life, we've discovered by looking at ourselves and our world.
Life on Earth is extremely diverse. Millions and millions of species of all kinds.
And these endless, beautiful forms occupy just about every available niche on the planet.
We've had the opportunity to explore a variety of extreme environments. And in pretty much all of them, we find life.
Earth has taught us that, given the right conditions, life is remarkably adaptable and resilient.
Life. Here on Earth, it is absolutely everywhere. Once life got started, it has held on tenaciously. But where can we find life elsewhere in the universe? If it's done so well here on Earth, certainly this can't be the only place. But if we're gonna find life on other worlds, we're gonna need to know where to look, because there's a lot of worlds out there, and man, is the volume of space huge. So you can't just go looking willy-nilly. You need to find a marker that guides you to where life most likely can be found. For life to get started on a planet, it needs a few specific things. You have to have energy to power that life, and you have to have the right chemistry. But even if you have both of those, there's still one more thing that we don't know is necessarily going to be found on exoplanets. Water. And it has to be liquid water.
Every single living thing on Earth requires liquid water to exist. To uncover life that resembles anything like what we have here, finding liquid water will be crucial.
There's a concept, follow the water, that where there's water, there might be life.
The universe itself is awash with water. Great reservoirs have been detected throughout the galaxy in vast interstellar clouds. But just because water is plentiful, that doesn't mean that planets are necessarily the places where it ends up. So while we've detected water on the moons of Jupiter and Saturn, only one of the 8 planets in our solar system has liquid water flowing on its surface. An ocean world where long ago, life began to thrive.
So the challenge then was to find an Earth-mass planet in a habitable zone, meaning it's the right distance from its host star to support liquid water on its surface.
Earth-like planets that orbit their stars at the same distance we orbit the sun were right on the limit of what Kepler could find.
We need to see the planet cross in front of its star, and it takes us multiple orbits to observe this. And so it's really, really difficult to find these planets.
And while Kepler can detect planets, it cannot tell what they're made of. To detect water, the most powerful space telescope yet must join the quest.
Kepler and Hubble worked well in coordination. Kepler would find planets around distant stars, and then Hubble would follow them up in more detail to teach us more about the atmospheres of the planets found by Kepler.
When the planet goes in front of the star, some of the starlight shines through the atmosphere. But just like shining a flashlight through the fog, some light doesn't make it through, and some does. And by piecing together which parts of the starlight make it through the planet atmosphere and which don't, we can actually tell something about the gases in the atmosphere of the planet that are absorbing. And then we can tell something about the makeup of the planet.
In 2015, Kepler finds Hubble a target. A world within its star's habitable zone. More than 8 times the mass of Earth, K218b is enormous. With a powerful gravitational pull that allows it to form and hang on to an atmosphere. Hubble examines light from K218b's star as the planet passes in front of it. And discovers a long-awaited signature. Water vapor.
K218b is exciting because with the Hubble observations, we found water vapor in its atmosphere. And this is the smallest planet to date, which sits in the habitable zone of its host star and in whose atmosphere water has been detected.
Earth has tiny but environmentally significant amounts of water vapor in our atmosphere, ranging from 4% to less than 1%.
So far, the data we have has shown that there's anywhere between 0.01% and about 15% water vapor in the atmosphere of K218b. And that might seem like quite a broad constraint, but we have to remember that this is a planet that's many, many light years away. So the fact that we can detect this water at all is already really exciting.
124 light years from Earth, we may have found evidence of water on another world.
K218b is a huge milestone. It's what we call a sub-Neptune-sized exoplanet.
Now, what does that mean? Well, it could be it's a planet sort of like Jupiter. Heavy, massive hydrogen atmosphere, no life. That's like Jupiter. Or it could be that water represents an ocean. It doesn't have a heavy atmosphere. Instead, it has an ocean, and the water's evaporating. So it's a wonderful discovery.
Within the data lies a tantalizing possibility. If K218b's vast mass is formed from water, its skies could be full of clouds, where water vapor collects, forming droplets, and eventually falling. A cycle, potentially feeding vast oceans that could stretch across the entire planet, making it a water world.
This finding is remarkable because 20 years ago, no one would have dreamt that we would be here today talking about detecting the atmosphere of a planet and trying to understand the conditions on its surface.
For me, K218b has been a real turning point because it really opens up the field to looking for life in these slightly bigger planets.
After the astonishing breakthrough of K218b, Kepler goes on to make many more discoveries.
So Kepler was a really simple mission. It's just this minivan-sized spacecraft that stared at this field of stars. But that one mission discovered so many alien worlds.
Worlds that astound astronomers and dramatically expand our understanding of the universe.
As we look out into the galaxy, we can start to answer the question of what properties do planets and planetary systems need in order to support the evolution and continued existence of life.
But nothing lasts forever. In October 2018, Kepler finally runs out of fuel.
It was sad to see an old friend leave when they sent the command to shut everything down. It's asleep now. It's in orbit around the sun and will continue that orbit.
To date, Kepler has given us over 2,500 planets. And we're still analyzing the Kepler data, so there could be many more to come.
A galactic census showing us just how common planets like K218b might be.
We know there's about, on average, 2 or more planets per star. Maybe 10% of those are small planets, 10% of those in the habitable zone. So that means there's about 20 billion planets about the size of the Earth in the habitable zone of their star.
We don't know about it, and we might never know about it, but it is absolutely possible that of the panoply of planets, of alien worlds that Kepler has observed, there's actually been some planets that host alien life.
Maybe they have their own forests and lakes filled with fish and skies filled with birds. It's so incredible to think about the endless possibilities that are out there for life to take.
These tantalizing glimpses of worlds give us a foundation to build upon
5,
for the next,
4,
even more
3,
ambitious
2,
mission.
1, 0. Liftoff. The SpaceX Falcon 9 carrying Tess, a planet-hunting spacecraft that will search for new worlds beyond our solar system.
Kepler taught us about statistics of how common planets are. But the planets found by Kepler were often orbiting stars that were too distant and too faint for further study. With TESS, we're looking at all of the nearby stars.
The vehicle has passed maximum aerodynamic pressure.
Because they are close and the stars appear bright to us, we can go and learn whether they have atmospheres, what the atmospheres are made of, whether they have moons and rings, all the stuff that is far too difficult to study for the Kepler stars themselves.
There were hundreds of people involved in making the TESS mission a success, and now the world is analyzing the data.
TESS is finding the planets that will make a legacy catalog that will be used for generations to come.
Among this vast array of worlds, what kind of life are we hoping to find?
When we say we're looking for life, we usually don't say exactly what we mean by that. And in fact, it turns out defining life in a way that satisfies everybody hasn't been done yet.
We have to distinguish between simple life and more complex, advanced life like ourselves. And there's quite a difference there between the two.
We are the product of a story that has been playing out for over a quarter of the age of the universe itself. From microbes to a global technological civilization. With our telescopes, we stand on the cusp of finding signs of at least simple life forms on other planets. But we have also been calling out, sending out transmissions into the galaxy in the hope of connecting with another intelligent species.
For millennia, we've looked out at the skies. And it's only in the last century, really the blink of an eye for humanity, that we've actually been able to send messages and probes beyond the Earth. And as of yet, we're still waiting for a response. What we're hearing is just silence.
But with millions of potentially habitable worlds in the Milky Way, why is no one calling to us? In 2020, scientists make an unsettling find. A planet, almost the size of Earth, floating freely through the galaxy, all alone.
Did it form there by itself, or has it been thrown out of another planetary system?
A planet that shows us that the galaxy is more chaotic and perhaps more hostile than we thought.
As we look out through the galaxy, there are many cases where planets would experience much more violent histories, and life might not be able to survive more than 1 billion years.
The rogue planet may be a refugee, telling us about systems far more chaotic than our own. Because not all stars exist alone. Some have company, orbiting one another in a careful dance.
So when we look up at the night sky and we see single points of light, which we assume are stars, often what's actually there are two stars orbiting each other, but they are so close together that they appear as one.
We're finding that these binary and multiple star systems are actually amongst the most common types in the universe.
Sometimes planets orbit both of these stars together, and other times a planet will orbit one of the two stars, but not the other star.
Dawn. Ushered in by not one star, but two. Perhaps the rogue world began its life in a binary system like this.
On a planet that's orbiting two stars, there would always be two shadows, and you would see two sunsets. I like to say that science fiction got some things right.
What does that feel like? The heat of two suns? Is that a nice heat, or is that too much? There's so many questions around binary star systems.
For a time, the planet may enjoy a stable period in the habitable zone of one of these stars. But the peace does not last.
The moment there's more than two bodies involved in a gravitational dance, things get complicated really fast. Because each body gravitationally affects every other body. On Earth, the most obvious manifestation of gravity from a body that's not Earth is the tides. The moon affects our tides. What can happen in these binary systems is that this strong gravity between these two stars can shift orbits drastically.
This huge combined gravitational force interferes with the planet's orbit, creating chaos.
There's a very thin line between stability and instability. And when instability kicks in, it goes from a stable system to a chaotic system. And at that point, anything could happen.
As each star and every planet in the system pulls the rest, the orbits of each world constantly shift, further adding to the turmoil. Until a close encounter with another world gives the planet a huge gravitational kick. Flinging it outwards. And releasing it from the grip of its parent stars. setting it loose. A rogue planet wandering the galaxy.
The planet will slowly start to cool down until it is just a rock with no source of heat, traveling alone through the universe.
Far from the warm embrace of its parent stars, any liquid water the rogue world might have once had freezes solid.
You would have the night sky all the time if you were on one of these planets, with no hope of a sun ever rising.
Any atmosphere that once protected it freezes. Leaving the surface exposed to cosmic radiation. Conditions which no living thing could endure.
It effectively becomes something of a dead planet. Almost a fossil of itself flying through space.
Alone and adrift. Only to be detected by us millions of years later.
The way we find rogue worlds is through a process called gravitational microlensing.
We look at a distant star, a star that has nothing to do with the planets that we're hoping to discover, and between the telescope that we're using and that distant star, a rogue planet wanders through.
The gravity of the planet is really small, but it's enough to bend that distant star's light so that we can see that it exists and measure its mass.
One of billions of planets on which the spark of life may have begun, only to be extinguished. Worlds where any civilizations could not have survived.
Our planet is a wonderful place to exist. We've been sheltered through history. We've experienced some large impacts, but we've had a relatively benign existence.
It could be that the reason we haven't found any alien civilizations yet is because we live in a particularly hospitable corner of our galaxy with just the right conditions for life to arise. Or maybe we just haven't looked hard enough.
Our quest for another living planet has only just begun. And the only way to know if we are alone is to keep looking.
I still feel very amazed that we have so much knowledge about these objects that are just so far away from us.
We have found our first rocky worlds. Some in the habitable zone around their stars. And even worlds with water.
Kepler has found thousands of new planets, but for every question that it's answered, it's raised at least 5 new ones.
Candidate worlds for future missions to search for the evidence of life itself.
I am actually very optimistic, personally, that we might find life within the next 10 years.
But we have also found hordes of bizarre, tortured worlds around violent stars. And rogue planets, where life as we understand it seems impossible.
What we see is a menagerie rife with diversity and worlds that we could never have imagined. It's like looking at those snowflakes under the microscope and seeing the wondrous structure that we never knew about before, but is beautiful and amazing to be a part of.
Perhaps it is these worlds that will help us understand why, for now, one planet continues to remain apart.
You might ask, why do we keep searching for these alien worlds? And I think the answer is profoundly human. We want to know what else is out there.
I think that it's not at all a guarantee that there's life elsewhere in the galaxy. And what we need to do is to go out and make measurements and to see which universe do we live in. Do we live in the Star Trek universe where every star has lots of planets with life and civilizations? Or are we, in fact, to the best of our ability to measure, truly alone?